section 9.3 is on phasors. Phasors is how we represent sinusoids easily, and it's going to make circuits so much better than they were in chapter 7 and 8. So if you're going to like what we're doing, stick with it here. So complex numbers. Z equal x plus jy. We all know that as rectangular form. Rectangular. J is equal to the square root of -1. Some of you may be used to using I. It's the same thing. It's just the square root of -1. Z equal R at an angle of phi. That's polar form. That's what we use for phasors. And then Z equal R e to the j phi. That's our exponential form. So we can write any complex number in any of these forms. So here's a little picture. We have some x, some y. Right here is our r. The angle's phi. And then this point is represented by x dot j, or plus jy. If I want to represent that with polar form, then I would have r equals the square root of x squared plus y squared. And phi, that's a terrible phi, equal tangent to the -1 of y over x. So you'll see these on your equation sheet that I've provided you to use with the end of the chapters here. So there's no need to memorize these. You're going to be given these on exams. But here's how we're going to go back and forth between polar and rectangular. So some math is pretty easy to do in rectangular. If you have some, let's say z1 equals x1 plus jy1, and a z2, that's x2 plus jy2, and we want z1 plus z2, well then we just add the real parts and the imaginary parts. We have x1 plus x2 plus j, y1 plus y2. Where it becomes a pain in the butt is when we need to multiply them. So if we want z1 times z2, well now we got to do a whole bunch of stuff, right? We end up with an x squared, then plus x1, y1, j, and then plus j, x2, y2, and then plus -1 is blah, 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 blah. Takes forever. So this is a pain. So that's when we want to use our phasor notation because it makes the math easier. Phasor, polar, same thing. So rectangular, it's a pain. But in polar, if I want z1 times z2, all I have to do is multiply the two r's. So if I'm representing z1 as r1, phi1, and z2 as r2, phi2, now z1, z2 is r1, r2, and we add the angles, phi1 plus phi2. So it becomes very, very simple. So that's addition, that's multiplication. Division, again, in rectangular, huge pain in the butt. But in polar, we have z1 over z2. That's just r1 over r2. And we subtract the angles, phi1 minus phi2. So your book lists all of them, the reciprocals in there, the power, the complex conjugate. I'm not going to sit here and go through them. You can look at them. It's very simple. But this is, the why we want to use the phasor notation. So how do we get there? Well, if we have some v of t, let me switch colors here for us. We have v of t equals Vm cosine omega t plus phi. So there's our sinusoid. And we want to represent that in polar form, or as a phasor. Then we say V is Vm at an angle of phi. That's all we have to do. So our peak voltage is our R, our phase angle is here. Now, one important thing to note, if you're going to do some sort of math on this now, you have to be adding it to something else that has the same omega. They have to have the same omega. If they don't, you can't do the math on them, and we'll see that as we go along. If, well, we can skip that for now, so that's good. So let's look at a couple example problems within this video, since it's a pretty short, easy to understand section. So this is problem 9.6, or 9.16, and we're asked just to transform to phasors. So we're given v of t equals minus 10 cosine 4t plus 75 degrees. Well, I have a minus sign in there. I want that to be a plus, so I'm going to shift this by 180. So I can write this as plus 10 cosine 4t plus 75 degrees minus 180 degrees, or 10 cosine 4t minus 105 degrees. And now my phasor is just 10 at an angle of minus 105 volts. We should still use our units. So that's one of them. Let's get a green marker out to do the next one. Actually, I think I'll skip the next one. It's pretty easy. We'll go down to one below it. V of t equals 5 sine 20t minus 10 degrees. All right, so it's a sine. I need to transfer that to a cosine. 5 cosine 20t minus 10 degrees. Going from sine to cosine, so I need to subtract 90 degrees. 5 cosine 20t minus 100 degrees. And now my phasor notation is just 5 at an angle of minus 100 degrees volts. So we'll go ahead and look at one more real quick, in yellow, I guess. V of t equals 4 cosine 2t plus 3 sine 2t. So I have the same omegas, 2t and 2t. That's good, right? That means that I'll be able to do this addition. I want to get this in terms of cosine. So 4 cosine 2t, not doing anything to that first one, plus 3 cosine 2t, shifting from sine to cosine, minus 90 degrees. And now I have, in polar form, 4 at an angle of 0 degrees, plus 3 at an angle of minus 90 degrees. Addition in polar form isn't that easy, so I need to put that into rectangular form. So this would give me, I don't think I wrote going the other way over here. If you have x, it's r, I lost it. What is it? Square root, here it is, x equal r cosine phi, y equal r sine phi. So over here, I'm going to have 4 cosine 0 plus j 4 sine 0, the first term, plus 3, this is my x, so 3 cosine minus 90, plus j3 cosine, sine, erased enough, sine minus 90. And if we do that, we get something here, 4 minus j3. Turning that back into a phasor, I have the square root, 4 squared plus 3 squared, at an angle, tangent minus 1, y over x, minus 3 over 4. And And we get a final answer over here. Where'd it go? 5 at an angle of minus 36.87 degrees. Couple notes about your calculator. Your calculator can do phasors for you. You know, it's important to know how to go back and forth between them, but you can also, when you're doing, you know, chapter 10 as we go along later, you can use your calculator to do this math, and it makes it very, very simple. Every calculator is different on how this works, so I would encourage you to Google your calculator with the word phasors. See if you can find an instruction sheet. There's a lot of them out there for every calculator that people are using. But, you know, at this point right here, if you punched this step into your calculator, it would spit out this answer. So you would skip this middle line here. Then you can tell it to go from rectangular to polar, and it will give you this answer. So I really encourage you to learn your calculator. It's going to make this chapter and the next chapter a lot easier.